Welcome back, students. In this video, we'll be doing question number 2 and question number 3. Okay, so this is the question given to us. Okay, there is actually an error here. It's positive odd integer. Okay, I forgot there's a typo. I made a mistake with that. I forgot that. So this is given. We have to show that any positive odd integer, okay, is in the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is an integer. Clear? So first, let's understand what an integer is. Integers are usually any numbers of the form 0, plus minus 1, plus minus 2, plus minus 3. Yes? Okay. So I hope you're clear, and so on. Okay, it goes up to infinity, plus minus 4, plus minus 5. Any integer which is, if it's 0, 1, 2, 3 or minus 1, minus 2, these are all integers. So we have to show that any positive integer, clear? Now remember, we're only dealing with positive odd integers. This is, so positive integers are going to be, first let's understand what is an odd integer. Odd integer is those integers which is not divisible by, or which is not a multiple of 1. So 1, 3, 5, 7, 9, 11, these are all odd integers, right? Because you cannot, they are not divisible by 1. Clear? In the sense, see, when you say odd integers, it also includes minus 1, minus 3, minus 5, okay? Minus, these are all odd integers, but here they have specifically mentioned positive odd integer. So we can only consider these values. It will go on, okay? 13, 15, 17, 19, 21, these are all positive odd integers, okay? So we have to show that any positive odd integers is in this form, okay? 6q plus 1, 6q plus 3, 6q plus 4, where q is some integer. Again, this is an important statement. It is some integer. So q, for this case, can take any value. It can be 0, it can be 1, it can be minus 1, it can be 2, minus 2, 3, minus 4, minus 10, minus 15, 20, 30. It can take any values, okay? So first, let us write what we need. We are asked to find a positive integer. We are asked to show, right? So I'll say let a be any positive integer, all right? We'll represent the positive integer to be an a. Apart from that, what do we have, and what is b? If you see, the divisor for all of this given equation is actually c, right? 6 is common to all. So I'll take a to be my 6q plus r, or let's just say by Euclid's division algorithm, by Euclid's division lemma, okay, not algorithm, division lemma. What do we have? We have that a equals to bq plus r, right? Where a is the dividend, b is the divisor, q is the quotient, and r is the remainder. So what do we have for b here? It is 6q plus r. And another interesting statement is that r must be less than b or equal to 0. So in the case of this, r must be less than 6 and it must be greater or equal to 0. So the possible values of r, okay, the possible values of r is equal to, what are the possible values? It's going to be 0, 1, 2, 3, 4 and 5, okay? So now let us take when r is equal to 0, okay? So a is going to become equal to bq, or 6q plus 0. So a is equal to 6q, okay, in 1, okay? Now when r is equal to 1 in 1, all right? So a is going to be equal to 6q plus 1, all right? Now if you pay attention to this, 6q is going to be an even number, right? Because you like, see, q is an integer. You can substitute anything for q, right? It can take 0, 1, 2, minus 1, minus 2, any numbers, okay, of this form, which is an integer, if you multiply it with 6. So 6 into 1 is 6, 6 into 2 is 12, 6 into minus 1 is minus 6, 6 into minus 12 is minus 12, 6 into 3 is going to be 18, and so forth. So when you look or focus on all these numbers, these are all going to be an even number, okay? So 6q is also going to be an even number, but 6q plus 1 is going to be an odd number, right? Because you multiply 6 and put q, and you add plus 1, 6 plus 1, or 12 plus 1, or after that 18 plus 1, right? Remember, 6 into 1, this is, okay? Now this is going to be 6 into 2 plus 1, this is going to be 6 into 3 plus 1. So when you look at all of this, or you equate this, you're going to get only odd numbers. Clear? 6q plus 1. Similarly, when r is equal to 2 in 1, your a is going to be equal to 6q plus 2, which is going to be an even number, okay? Now when r is equal to 3, your a is going to be equal to 6 cube plus 3, and this again is going to be an odd number. All right. Okay. Now when r is equal to 4, your a is going to be equal to 6 cube plus 4, which is an even number. All right. And finally, when r is equal to 5, your a is going to be equal to 6 cube plus 5, which is going to be an odd number. Okay. See, I'll tell you one thing, you just keep substituting the values. Q is an integer, okay? So Q can be any values that you want. Plus, minus 1, plus, minus 2, plus, minus 3, and so forth. So what you're supposed to do is you put Q is equal to 0, you put it 1, you put minus 1, you put it in this equation. For example, I'll keep this in this equation, okay? And I'll say my Q is 0. So 6 into 0 plus 3, how much do you get? This is 3, right? Now when Q is equal to 1, let's put 6 into 1 plus 3, how much do you get? 6 plus 3 is equal to 9. Similarly, when a is equal to 6 into, I'll put 2, okay, plus 3. See, I'm taking this equation, okay, do not get confused. So this is going to be 12 plus 3, that is going to be 15. So if all of these numbers, 6, 9, 3, these are all odd integers, right? They are all odd numbers. So just like this is just for rough work, okay, for your understanding. Just like this, you keep on substituting values for Q, even for this and this, okay? You'll realize that 6Q plus 3 is going to be odd, 6Q plus 4 is going to be odd, okay? Hence, 6Q plus 1, 6Q plus 3, 6Q plus 5 are the form for the only form for an odd or positive for positive odd integer. Okay. All right. If you're done with this, okay. Quickly, let's move on to this question. Okay. Now, this is given: an army contingent of 606 members is marched behind an army band of 32 members in a parade. The two groups are to march in the same numbers of columns. What is the maximum number of columns in which they can march? Okay, the maximum numbers of column in which they can march. So we have 606 and 32. So which is greater? Obviously 616 is greater, so we find the HCF. Okay, we find the HCF. Okay, remember it's maximum number, so it's the highest common factor. Okay, all right, so this is the highest common factor that we have to find. So in order to find out the highest common factor, this is how we normally do, right? So you take 616 and you take 32. Okay, so we'll first try to find out for 31. 32 into 2 is 64, so we can only take 31. So I mean 32 into 1. So 32 into 1 is 32. So 11, then 5. So you have 2 minus 9, 296, right? So again, 32 into 9 gives you 288. 32 into 9 gives you 288. So what is left over here is 16 and just 8. So that's going to be 8 itself. Okay. All right. So 606 is 32 into 19 plus 8. All right. Lastly, 8 into 32. Clear? So you can write this as 32, and that is the dividend. Our divisor is 8. So it's easy. 8 into 4 is 32. So 8 into 4 gives you 32. Therefore, HCF of 616 and 32 is 8. Therefore, the maximum number of columns in which they can march is 8. Okay, so we'll end the video here.